Assalamualaikum dan salam sejahtera. And now we are going to look at calculation that involve in this subtopic. Okay, so let's start. Now we look at the dissociation constant. Okay, before this, you already learned about equilibrium constant in chapter 6. We have Kc, we have Kp, and now we have Ka, we have Kb. So Ka, Kb adalah dissociation constant. Ka, A stand for acid, while B will stand for base. Okay, so Ka, Kb, strong acid and strong base do not have meaningful of Ka and Kb value. Why? Because strong acid and strong base dissociate 100%. So macam mana nak kira Ka, Kb? Dia dah dissociate completely. So dissociation constant here only for weak acid and weak base. Okay, only for weak acid and weak base. Alright, so how to write the formula or how to write the expression for Ka and Kb? So the expression still same like Kc. Kp tak ada dalam chapter 7. Okay, so Ka dengan Kb we just focus on the concentration sahaja. So senang lah, tak payah fikir Kp ke Kc kan. Okay, so dia fokus pada concentration. So still same, concentration of product divided by concentration of reactant. Okay, for example, if you want to write the Ka expression for this weak acid, okay, look at the product. Okay, so we have H3O plus. Okay, this equation already balanced, times with concentration Cn minus. So all the mole here 1 to 1 kan. Divide by concentration HCN. Okay, for H2O we just ignore it. Sama macam Kc. Okay, pure liquid, pure solid will not involve in the constant, equilibrium constant ataupun dissociation constant. Boleh? But for chapter 7, for chapter 7.1, kita takkan ada solid lah. Mostly adalah liquid. Liquid come from water. Okay, dan semuanya kita akan guna aqueous. That's why kita tidak ada Kp. Okay, semuanya adalah aqueous, sebab tu tidak ada Kp. So all concentration. Okay, for Kb also here we have weak base, so H2O also we just ignore it. So if you write the Kb expression, okay, it should be like this: concentration of the product NH4 plus times with OH minus divide by concentration NH3. So without H2O. Okay, so all the ratio here 1 to 1. Boleh? So very simple. So A stand for acid, B stand for base. Okay, so the relationship here, okay, kita boleh summarize sikit. If there is stronger acid, the concentration of H2O plus should be higher. So the value of Ka larger. Or if the stronger base, ini based on weak acid and weak base saja ya. Okay, stronger base, concentration OH minus will increase and the value of Kb larger, or vice versa lah. Okay, so ini adalah basic concept in acid and base. So kalau lagi banyak concentration H2O plus, lagi tinggi lah kekuatan acid tu. Kalau lagi banyak concentration OH minus, lagi kuat lah suatu base tu. Okay, boleh? Next, auto-ionization of water. Auto maksudnya automatic. Right? So before this, in H2O, dalam air, okay, bukan hanya ada satu saja molekul air. Betul tak? Ada berjuta-juta lemon molekul air. So when the molecule of water react with another water molecule, okay, so bila dua ni bertindak balas, alright, so we know that H2O are able to act as acid or act as base. So if another one act as acid, another one act as base, so it will produce H3O plus and OH minus ion. So one will donate H plus, another one will accept H plus. So dia akan jadi H3O plus, OH minus. So that's why water adalah neutral, because it consists of two ion, H3O plus and OH minus. As we know, acid only consists of H3O plus, but base only consists of OH minus ion. But for water, why? Water boleh jadi amphoteric, boleh bersifat amphoteric because of this reason, because it contain of H3O plus and OH minus. So for water, dia ada satu formula, formula baru. Tadi KAKB, sekarang KW. Okay, what is KW? KW is ion product constant for water. So this value of KW 1.0 times 10 power negative 14 here, the value is constant. So tak perlu hafal, boleh refer dalam list of constant value. Boleh? So this formula tolong hafal. Okay, KW equal to concentration H3O plus times concentration OH minus. Okay, W stand for water, A stand for acid, B stand for base. Kita dah jumpa tiga. Mana tiga? Kita dah ada KC, KP, KA, KB, KW. Okay, so dah ada 5 jenis constant. Okay, so here in pure water, the concentration of H3O plus and OH minus here same, 1.0 times 10 power of negative 7 molar. Ni tolong ingat juga. Okay, so nilai concentration of OH minus and H2O plus sama, sebab tu pure water adalah neutral. Okay, sebab tu pure water adalah neutral, tidak berasid, tidak berbase, because of the concentration H3O plus and OH minus equal. So kalau concentration H2O plus lebih tinggi, dah jadi lain dah, kan? So kita tengok kat sini. Okay, if the concentration of H3O plus higher than OH minus, means that solution should be acidic solution. If the concentration H3O plus equal to OH minus, like pure water just now, it should be neutral solution. While if the concentration OH minus bigger than H3O plus, it should be basic solution. So this concentration OH minus and H3O plus you can calculate by using formula KW. Okay, sebab KW nilai dia adalah constant. 1.0 darab 10 kuasa negatif 14. So kalau awak nak kira concentration H2O plus dengan concentration OH minus, boleh directly use this formula. Okay, next we look at the pH. Pernah dengar kan pH? Sebab kita tahu kalau pH 7 neutral, pernah kan? Pernah tahu kan? Ni basic knowledge. Below than 7 acid, more than 7 base. That's the basic concept. Okay, so now for this chapter you are going to learn how to calculate the value of pH. Sebelum ni awak just pakai pH paper je nak tahu kan. So awak boleh kira sebenarnya pH ni by using formula, this formula. Dah banyak dah formula kita jumpa ni. Okay, so this one also you need to remember. pH equal to negative log H3O plus. Negative log H3O plus, concentration H3O plus. So if you have the concentration H3O plus, so you can calculate the value of pH. Okay, Next, ini mungkin tak pernah dengar. POH. So POH normally for base, base tak boleh direct kira pH. Awak kena kira POH. So POH is negative log times with concentration H3, bukan H2 plus, OH minus. Okay, so sebenarnya kelas, this P here stand for negative log. Okay, P here stand for negative log. So kalau awak tekan kalkulator tu negative log. Okay, and from pH, kalau you ada pH, awak boleh kira H2O plus juga concentration. So macam mana? So if you want to calculate the value of concentration H2O plus from pH, what you need to do? Bila you tekan calculator tu nanti, kan, you kena tekan shift. Saya ulang, tekan shift log. So dia jadi anti-log. Okay, shift log dalam bracket negative pH. Baru dapat concentration H2O plus. Okay, so ini cara awak tekan kalkulator tau. Sebab ini ramai ni yang pelajar tak reti tekan kalkulator ni. Anti-log ni ramai pelajar tak reti nak tekan. Macam mana nak tekan tadi madam kata? Shift, tekan shift, tekan log, negative pH. Baru dapat concentration H2O plus. Okay, boleh? Okay, next. So this is the relationship between concentration and pH. So the higher concentration H2O plus, the lower the pH. Makin tinggi concentration H2O plus, kita tahu kalau pH kosong tu, pH kosong adalah memang asid yang paling kuat. Okay, so the higher the concentration OH minus, the lower the POH. Okay, next we look at the relationship between KW, PKW. Ada PKW pula kan. Bukan lu PK lah sendiri, bukan. Okay, so kita ada KW, PKW. So you all dah boleh fikir dah, P ni stand for apa tadi madam kata? Negative log. So maksudnya kalau PKW ni negative log KW, pH and POH. So what is the relationship between these four symbol? Okay, so kita tengok. So this is the formula of KW. If you tekan calculator, you tekan negative log. Okay, saya tak ulang. Kalau you tekan calculator, negative log 1.0 darab 10 kuasa negatif 14, you akan dapat nilai 14. Okay, so PKW adalah sama dengan 14. Saya ulang, PKW sama dengan 14. So kalau awak negatif logkan nilai ni, awak akan dapat 14. Okay, so sebenarnya pH plus POH should equal to 14. So ni tolong ingat ni. Ni penting ni nanti dalam calculation. Okay, pH plus POH equal to 14. Okay, degree of dissociation. So for this formula, we already look at the chapter 6. Kita dah pernah jumpa dalam chapter 6. And now I don't want to repeat lagi kat sini banyak kali. Okay, formula dia sama. Change in concentration of reactant divide by initial concentration of reactant. Okay, so if percentage, you just times with 100. Okay, sama konsep macam chapter 6. And now we are going to look at the example of calculation. How to apply all the formula that we have here into question. Okay, so jom kita tengok sama-sama kan, sebelum awak buat soalan tutorial kan, at least madam boleh beri sikit gambaran, okay, untuk you all macam mana nak buat pengiraan. Okay, so kita tengok dalam soalan. Dia kata calculate concentration H2O plus, Cl minus and OH minus and the pH of 0.015 molar HCl. Okay, so what we need to do, we need to write the equation first. Okay, so we know that HCl adalah strong acid. Betul? Kalau awak masih ingat lah, HCl adalah strong acid. Okay? So, untuk strong acid, kita kena construct table. Dalam chapter ni banyak kena construct table. Ice table pun ada. Kejap lagi kita tengok. Okay? So, untuk strong acid and strong base, kita tak pakai ice table. Kita pakai initial final table. So, in this chapter, kita tak ada pressure. So, semuanya adalah concentration. So, the unit of concentration should be molar. Okay, so we write the equation first. So, kita ada HCl aqueous react with H2O liquid. Ingat, H2O je yang liquid. So, strong acid mesti straight arrow. Produce H3O plus aqueous, okay, plus Cl minus aqueous. Okay, nampak? So ion semua aqueous sebab dia dalam solution. H2O je liquid. Okay, yang lain semua aqueous. Okay, look at the info we have. Kita ada 0.015 molar HCl. So ini adalah initial concentration. Okay, so initial concentration for HCl yang diberi adalah 0.015. So initial concentration for H2O ada ke? So H2O will not involve in the calculation. So we just ignore it. And look at the product. Initial dah ada ke produk? So dalam chapter 7 ni senang, tak payah fikir dah reverse ke forward reaction yang akan berlaku. Chapter 6 je yang kena fikir. Chapter 7 tak payah, sebab nilai yang diberi memang nilai initial concentration for reactant saja. Reactant yang mana? Left side. Produk memang semuanya kosong, belum buat tindak balas, belum dissociate. Macam mana nak tahu? Kan? Belum dissociate, semuanya kosong. Okay, final. So we know that strong acid will dissociate completely 100% into water. So no more HCl. Okay, so 0. Nampak? Okay, and then for the product macam mana? Produk dia dah completely dissociate. Means bila dia kata completely dissociate, the concentration of the product should equal to the initial concentration of the reactant. Sama, salin je. Okay, senang, boleh nampak? Okay, so next kita nak kira concentration H3O+. Perlu kira ke? Dah dapat dah dalam table. Okay, so boleh terus ambil H3O plus equal to 0.015 molar. Unit jangan lupa. Ramai yang suka tertinggal unit. Cl minus concentration also kita dah dapat juga 0.015 molar. And then how to calculate the concentration of OH minus. Macam nak kira? Dalam table tak ada concentration OH minus. So macam mana nak kira ni? Ada satu formula that relate OH minus with H3O plus, which is, yes, Kw equal to concentration H3O plus times with concentration OH minus equal to 1.0 times 10 power of negative 14. So, you can directly calculate the concentration OH minus. Kan? Boleh terus kira. So, you dah dapat 1.0 darab 10 kuasa negatif 14. Okay. So, divide by 0.015. So you akan dapat berapa? 6.7 darab 10 kuasa negatif 13 molar. Okay, tak nampak 13 nya kan? Padam jap. Okay, 13. Alright, so this is the concentration OH minus. Boleh? Okay, last one kita nak kira pH. How to calculate pH? Ada formula kan? Apa formula pH? pH equal to negative log concentration H3O+. So, we have the concentration of H2O+. So, directly substitute into the formula. So, you will get, press your calculator, negative log 0.015. So, the answer is 1.82. Saya dapat 1.82. Nak tekan calculator dulu. Okay, 1.82. Okay. So, kalau boleh, pH ni ambil dua decimal places. Ataupun 3 significant figure. So, this is the answer. So, how you apply all the formula here? So, this is for strong acid. Okay. Alright, next we are going to look at the example of weak acid. If you refer to the slide before this, hydrogen fluoride adalah kategori weak acid. So another clue class, another clue, if we want to know whether this is weak acid or strong acid, the clue is look at the value of Ka given in the question. Before this, HCl ada tak diberi nilai Ka? Tak ada kelas. So this is the tips. If the question give you the value of Ka or Kb, means that acid or that base should be weak acid and weak base. That's the clue. Sebenarnya kan, tadi Madam kata kalau tak hafal pun tak apa. Kalau hafal lebih baik, kan? Okay, so that's the biggest clue yang boleh Madam bagi tahu. Okay, so kita dah tahu dia weak acid. So kalau weak acid, soalan nak cari apa? Soalan nak cari pH. Tadi kita dah tahu formula pH, negative log concentration H3O+. So, macam mana nak selesaikan? So, kita kena cari concentration H3O+ dulu. Untuk weak acid, you all kena construct ice table. Wajib. Saya ulang. Wajib buat ice table. Tak payah fikir macam chapter 6. Kalau chapter 6 kena fikir, nak kena buat ice table ke tak? Soalan ni nak kena buat ke tak? Ini tak payah fikir. Wajib buat. Strong acid, strong base, guna initial final table. Weak acid, wajib buat ice table. Apa yang kena ada dalam ice table tu? Initial concentration, change of concentration, ini semua molar, equilibrium concentration. So, mesti ada 3 row. Okay, tak ada pressure ya. Saya dah bagi tahu banyak kali dah ni, tak ada pressure sebab kita bermain dengan aqueous phase. Okay, so dekat sini kita akan ada, kita buat equation dulu, wajib buat equation. Okay, HF, aqueous, acid kan, react with H2O, liquid, produce, look at the arrow, we use the reversible arrow here, produce H3O+, acid mesti hasilkan H3O+, plus F minus. Okay, so this is the equation. Dalam chapter 7 ni, benda yang tak beruntung adalah tak ada equation yang diberi. Kalau chapter 6, equation kebanyakannya diberi, balancing equation. But for chapter 7, you need to write your own equation. That's why you need to be careful lah. Sama ada kena guna arrow straight ke, reversible arrow ke. Sebab tu kena kenal weak acid, weak base, strong acid, strong base. Okay. Okay, now the first info we have here is the concentration of HF here. Kita dah ada concentration kat sini. Okay, so concentration yang diberi, Madam kata dia mestilah initial concentration. Okay, sebab HF punya kan. So kita masukkan dalam table, concentration initial HF adalah 0.5. H2O kita boleh dash saja, abaikan. Okay, And then for H3O plus and F minus, the product 0. Okay, senang cerita saya cakap kat sini, produk memang semuanya kosong. Belum buat reaction lagi kan? Mestilah kosong, tak ada lagi. Okay, next, the second row, we have change of concentration. So change of concentration, we are going to use the symbol of X. So kita tahu reactant akan berkurang, so negative X. Kenapa 1X je? 1 mole. Okay, and then here positive X, here positive X. So for the equilibrium, 0.5 minus X. So here X, here X. Okay, so finish about the ice table. Fahamkan dulu. Okay, next kita kena cari X lah. Nampak kita kena cari X. So before we calculate the value of X, we need to write the Ka formula. Okay, so the Ka formula is concentration product H3O plus times with concentration F minus divide by concentration HF. Okay, so this is the formula. H2O will not involve in this formula. Okay, and then we just substitute the value. So kita akan ada H3O plus F minus XX, bukan 2X. Ada yang silap hari tu. So dia jadi X squared divide by 0.5 minus X equal to, yes, kita dah ada nilai 7.1 times 7.1 times 10 power of negative 4. Okay. Okay, so if we look at this equation atau formula ni, mesti kena selesaikan quadratic equation. Betul tak kelas? Alah, nak kena selesaikan quadratic ke? Kelas, tak payah kelas. Kan? Cuma chapter 7 ni lagi senang. Korang kena buat assumption. Apa assumption yang korang kena buat? Okay, kalau awak tengok nilai KA dia kecil. So, KA value less than 1, terlalu kecil daripada 1. So, kita boleh assume, okay, kita boleh assume that X very small. X tu apa sebenarnya? Dissociation kelas. So, the dissociation of weak acid very small kan, kita tahu very slightly into water. So kita boleh anggap X tu terlalu kecil. So bila X terlalu kecil, so kita boleh buat assumption dekat sini. Okay, assumption dekat sini kita boleh buat 0.50 tadi tolak X, dia akan jadi 0.50 saja. X yang ada tolak X tu abaikan. Hanya yang bahagian bawah ya. Kita hanya assume yang bahagian bawah ini saja. Atas tak jangan abaikan semua, kalau tak macam mana nak kira nanti. Okay, so now KA awak akan jadi X squared divide by 0.50 equal to 7.1 times 10 power of negative 4 sahaja. So, no need to solve the quadratic equation. You can directly calculate the value of X, 0.019. So, this is the value of X. Okay, after we get the value of X, sebab tadi konon tak nak buat quadratic equation kan. So sebenarnya memang kita senang kerja, tak payah buat quadratic equation. But class, we need to check whether our assumption diterima ataupun tidak. Awak kena check. Kalau awak tak check, salah. Okay, awak kena check. So awak kena check nilai X yang awak dapat ni 0.019 ni boleh dipakai ataupun tidak. Kalau tak boleh digunakan, awak kena selesaikan quadratic equation. Okay, so macam mana nak check? Menggunakan 5% rule. How? Okay, you just use the formula of degree of dissociation ataupun percentage ionization, which is the formula is concentration of reactant divided by change of concentration of reactant divided by initial concentration of reactant times 100, like this. Okay, so this is how you checking the assumption. Kita nak tahu assumption kita ni boleh terima ke tak. So di mana X ni adalah change of concentration, 0.5 ni adalah initial concentration. Ini kan formula degree of dissociation ataupun percentage ionization. Okay, darab 100. So masukkan nilai X yang kita dapat tadi dalam ni, kemudian awak dapat 3.8%. So bila kurang daripada 5%, ini yang dipanggil 5% rule tu. Okay, bila kurang daripada 5%, bermaksud your assumption is justified. Kenapa kurang daripada 5%? Sebab ini weak acids class. Kita tahu kalau weak acid, dissociation dia sangat kecil. Okay, sebab very slightly, dia tak macam strong acid 100% dissociate, betul tak? So bila kita anggap dissociation dia terlalu kecil, kurang daripada 5%, bermaksud this assumption we can accept. Maksudnya betul lah ini weak acid. Maksudnya dia punya apa orang kata, nilai X tu memang terlalu kecil, perubahan dia memang terlalu kecil, so kita boleh terima. So awak punya assumption here accepted. So no need to solve the quadratic equation. Boleh faham? So you boleh guna nilai X tu untuk kira pH. So X actually refer kat siapa? Tengok balik dalam table. X adalah refer kepada concentration H3O+. So kita dah dapat concentration H3O+ adalah 0.019 molar. Okay, but this is not what we want. Soalan nak cari apa? Soalan nak cari pH. So to calculate the pH, the formula is negative log concentration H3O+. So substitute the value and you will get the answer is 1.72. So this is the answer for pH for hydrogen fluoride. Okay, next. Last question. Last question untuk saya bincang. Tadi kita dah tengok weak acid and now weak base. Okay, so how to find the value of pH for weak base? Macam mana nak cari kan? Kenapa? Apa bezanya? Dia lebih kurang sama je kelas cara dia. Tapi ada beza sikit je. Okay, jom kita tengok sama-sama. Okay, why we know this is the weak base? Kenapa kita tahu CH3,2NH ni adalah weak base? Okay, yang pertama clue dia sebab ni adalah amine. Sebab dia ada nitrogen atom. So amine kategori weak base, if you still remember. Okay, and the biggest clue here because we have the value of Kb. Kb hanya untuk weak base. So itu clue yang paling besar. So the question asks you to calculate pH. So bila kita tahu dia adalah weak base, what we need to do? Yes, you need to construct ice table. Tak boleh lari. Okay, so jom kita buat equation dulu. Okay, so macam biasa buat equation dulu. So ini semuanya concentration ya. Okay, tak ada pressure. So kita ada CH3 2NH aqueous. Okay, so react with H2O. Okay, untuk equation lagi senang awak apply Bronsted-Lowry definition. Okay, so kalau Bronsted-Lowry kata base should accept proton, kan? Dia akan terima proton. Okay, so kat sini reversible arrow. So dia akan dapat apa? Okay, OH minus aqueous plus sebab H2O yang akan donate. Okay, base akan terima kan? So dia akan dapat kat sini CH3 2. Okey, nak terima dekat siapa? Okey, saya ulang Tolong tambah hidrogen pada nitrogen. Saya ulang, tolong tambah hidrogen pada nitrogen. Sebab nitrogen tu yang bersifat base. CH3 tu tak bersifat base ya. Yang bersifat base adalah pada nitrogen. Okay, so dia akan jadi, sebab dia tambah H+, so dia akan jadi NH2+. Nampak sebab dia tambah H+. Okay, so phase dia phase ion semua aqueous. Alright. Okay, next kita nak selesaikan. So in the equation in the question we have the initial concentration for this amine. Alright. So the initial concentration 1.5. Okay, H2O just dash saja, not involved in this calculation. Okay, OH minus and the other ion 0. Okay, sebab belum mula tindak balas lagi. Okay, next for the change of concentration, negative X here positive X sebab balance. Yang bestnya chapter acid base ni selalunya lah, semua ratio dia 1 to 1 selalunya. Okay, tapi tengok betul-betul tak semuanya bernasib baik macam ni. Okay, and then change of concentration dah, equilibrium concentration 1.5 minus X here X here X. Okay, so next what we need to do, yes, write the KB expression. Okay, concentration of product, so kita ada OH minus times with CH3 2 NH2 plus. Okay, so ini adalah concentration of product. Divide by concentration of reactant kita tadi, CH3 2NH. H2O tak ada lah. Okay, so equal to X squared. Divide by 1.5 minus X equal to 5.9 times 10 power negative 4. Okay, so what we need to do? Yes, no need to solve the quadratic equation. We just assume. Okay, so KB less than 1. So we assume that X very small. Okay, sorry tulisan buruk sikit. Okay, assume X very small and then assumption. Okay, 1.5 minus X equal to only 1.5. Boleh? Sampai sini? Okay, and then our KB akan jadi KB equal to X squared divide by only 1.5 equal to 5.9 times 10 power of negative 4. So we can get the value of X here. So the value of X here is 0.0297. Okay. Okay, now we already got the value of X. Same like question before this. Okay, so apa yang awak kena buat? You need to check your assumption whether it's justified or not. Diterima ke tak? Menggunakan apa tadi madam cakap? 5% rule. Okay, so kita check. Divide your value of X with the initial concentration. Okay, like this. Okay, X divide by 1.5 initial concentration times 100. So just substitute the value of X here and then we got the value of percentage here is only 2%. So assumption is justified because less than 5%. So this is the weak base. Maksudnya memang betul lah dissociation dia terlalu kecil. So boleh terima. Kalau lebih daripada 5%, your assumption tak boleh diterima. Awak kena selesaikan quadratic equation. Macam mana nak selesai quadratic equation? Macam chapter 6. Boleh kelas? Okay. So dah dapat nilai X, boleh teruskan pengiraan awak macam biasa. So kita boleh relate dengan apa value X ni? Yes, value X here adalah sama dengan concentration OH minus. Okay, so concentration OH minus sama dengan X. So 0.0297 molar. Nampak? Okay, but the question asks you to calculate pH class. Nak kira pH, you need the concentration of H3O+. You cannot use the concentration OH minus. So how, class? Ada dua cara, class. Cara yang pertama, buat macam saya buat. Okay, you kira pOH, di mana pOH adalah negative log concentration OH minus. Awak kira dulu pOH. Okay, dapatkan berapa nilai pOH. So kalau saya kira kat sini, pOH saya adalah 1.53. But we don't want pOH, we want pH. So macam mana nak kira pH? So ingat lagi tak relationship between pH and pOH? pH plus pOH equal to, yes, 14. So pH sama dengan 14 tolak 1.53. So akan dapat 12.47. So this is the value of pH. So inilah jawapan dia. Atau awak boleh guna KW untuk cari H3O+ concentration. Okay, awak boleh guna KW untuk cari concentration H3O+. And then bila you dapat concentration H3O+, sebab awak ada concentration OH minus, kan? Ingat lagi tak? KW sama dengan concentration H3O+ times OH minus. So boleh dapat concentration H2O+. So you boleh directly calculate pH by using formula negative log concentration H3O+. So for this question, for base, you boleh kira dua method. So ikut you all lah nak pakai yang mana. Boleh, kelas?